if I was starting a new project and I'm looking at my molecule and I'm trying to figure out which basis set to use, where would I go to find more information on how to select them?
You can go to the Gaussian homepage. They've got a nice little user manual. You just navigate through some things, and they'll give you a list of all of these basis sets and what they're used for.
Good. More questions? I have a probably relatively challenging question. So, I'm a bit lost in logical connections. What we do here should be one big picture, one story. How does your presentation relate to what was presented by previous speaker, by Audrey? Let me open this question in more details. Selection of basis sets is a technical tool to solve some problem. But which problem are you solving? What is your goal? And how this goal relates to the goals of previous speakers?
So, while I was reading about basis sets, I'm hoping this will answer the question, but I was finding all these PDFs and PowerPoints about what kind of jobs you would do and the kinds of molecules you would build and the kinds of basis sets you would use for those. So say let's take an anion. Let's build an anion. And what do we want to do with it? What do we want to do with this anion? Just spit something out.
Is it an answer or a question?
A little bit of a request in an attempt to help answer the question.
So, how would you answer this your little question?
Okay, so let's say we have our anion, and then we have something else that we want to interact with our anion in some way. What we can do is, since we know it's an anion, we need to include some sort of polarization function in our basis set. So we choose our basis set based on the kinds of things we're working with, like our anion, and whatever we have it coordinating to, I suppose. And then when we go in and we choose our calculation type, we can choose our job, we can choose our geometry optimization, we can choose frequency, we can choose scan, asp, etc., 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 etc. But I forget which one would be most useful for watching the coordination actually take place.
Can I help you in answering
Yes,
this?
please.
So let's focus on only single point, only on energy calculation.
Energy calculation?
Yes.
Okay.
In this aspect, what is your goal? How do you come to technical issue of selecting atomic orbitals, and how the single point calculation connects to geometry optimization?
We're talking about the single point energy. That's our minimum consistent field.
Yes.
Yes. Okay. Okay. Hold on, I'm trying to find words.
I'm not trying to challenge your technical knowledge.
No, it's okay.
It's more like global, big picture.
Global, big picture.
Yes.
We're selecting basis sets for big picture.
Yes. Relate
Okay.
basis sets to a big picture.
There, that makes a lot of sense. Big picture, big picture, big picture.
Let me start helping you further. Thank you.
Shoot.
So when Audrey presented the potential energy surfaces, there is a total energy of the whole molecule for a given interatomic positions. Where do we get this energy? Question to everyone. It's more a rhetorical question. So we need a prescription. We need a tool that would give total energy of a system for each position of ions. And it is a main problem, main question to computational chemistry. If atomic positions are provided, give us the total energy. This question is answered through solving electronic equations, through finding in which states electrons are and how they contribute to the total energy. Here is the big picture. And And then when you are solving for states of electrons, for molecular orbitals, you need to expand them. You need to cast molecular orbitals in some bases. And there are alternative ways to select a basis. Would you like to add or connect this to what you presented?
Not really either, but kind of anecdotal. A few years ago, I was doing some stuff with Gaussians in finding electron population densities in different radicals, and seeing if there was any spin delocalization when complexed with water. And so we had to figure out which basis set we wanted to use for that, which ended up being a CCP, not the VDZ, but I think it was some number instead of the D.
Okay. So the summary of this comment was that for some specific problems, some basis sets are more preferred than others. Okay, let's think.